and just salespeople and just like put them against each other in all these like physical contests.
Yeah, absolutely. Cool. We should get started. If you're
Okay.
ready, feel free to share your screen.
Sounds good. One sec. Is that coming up? Cool. Okay. So my project's be YouTube Mr. Beast. We're going to go into more about YouTube and kind of what measures success for them. So the data is on the top subscribed YouTubers. It's about the top 1,000. It comes down to around like 980-ish after a little bit of cleaning. This includes various variables that were compiled from various reputable sources on Kaggle. On there, it's global YouTube statistics 2023. The usability was 10.0, 100K views, 222,000 downloads. It was updated very recently, which is what kind of led me further to look at this data set. And the main focus here is to understand what we could find in this data that attributes to YouTuber success. So the why, other than YouTube is the most online or the most popular online video platform. And me personally, I have a connection where I'm like just completely dumbfounded by the idea that people could have a YouTube channel virtually and reach millions of people, make millions of dollars. And I feel like if you could quantify how or why people do that, that would be valuable, like, no limit on how much value that could be for someone. So if I knew this recording was going to reach 100 million people, what could I do with that? Is kind of a good question, and probably do a lot of different things. But everyone's used YouTube at some point or has, viewed a video from there. It's very relatable, growing popularity and user base, year-over-year revenue growth. People who could benefit here are aspiring YouTubers, current YouTubers who are just going about their current work and they want to see how data can affect that. Anybody on that trajectory can, alter their journey with some data. And someone curious like me, I just, curious how these people are so successful and why am I not so successful like that? All right, so data set specifics, like I was saying, it came with 995 records, 28 columns. Some to note, YouTubers, that's like their name or channel name, subscribers, video views, categories, uploads, country, highest yearly earnings, subscribers for the last 30 days, and video views for the last 30 days. They're gonna be the key ones we look at. There are more, but these are the most important ones that I found so far. And I add a couple earnings per sub, YouTuber count, the last 30 and regular view conversion and links. We'll go into that more later. And there were some errors with the data. There were some YouTubers that were listed as music, but it was the category. It had, tons of video views and subscribers, but like no earnings and, not accurate values for the rest of it. So I removed those. And category and channel type looked very similar. Channel type had a lot of values that weren't in line with what I researched YouTube to have actual for category type. So I imputed the missing ones from category with what those had and then spot filled in a couple of the top. And I adjusted some missing data in some quantitative columns. There were NaNs or zeros, and I used the means of the column for that. All right, so now we're going to jump into the data, see how these variables interact with each other. And main goal is to see what success means and how we can find variables that attribute to success. So first, we'll jump into country here. What's one thing that somebody might think about where they're starting their YouTube journey is where they're living. And we don't want people to give up based on where they come from or what country they reside in. So I took the top 5 countries here, and we have the United States at the top, India second, Brazil, United Kingdom, Mexico. And as we could see, out of the top 100 YouTube or top 1,000, like the more subscribers means the more earnings. And United States and India had by far the most YouTubers. United States had 311, India had 169, which, would make sense from if you were just thinking logically, like, why are they so far up there? Because more subscribers, more earnings come from more YouTubers. So yeah, good trend from here. Saw correlation between subscriber and earnings from what we could see. Yeah, so another big piece of being a creator is like what you're going to create and what category or your channel type is going to be, where your niche is. So do creators have to cater their content to certain topics, or do you want to flourish where your interests and your expertise is? So what I did here is by category, we have the top 5 by subscriber here. We have entertainment, music, people and blogs, gaming, and comedy. And top 3 here by far were entertainment, music, and people and blogs. But something interesting to note here, it's not the same as what we saw with country. We have gaming here having more subscribers but less earnings than comedy. So I thought that was a pretty interesting piece, and it's something we're going to want to keep in mind. So going forward, I wanted to kind of see what the top is doing in each of subscribers and earnings. So to dissect that, a lot to unpack here first. 2 bar charts here. I did on the left, top 10 subscribers. So if you rank it by subscribers, we have the top 10. And on the right, we did top 10 earnings. And I just want to see what the top people are doing in this data set and kind of see if there's something we could derive from there. As you could see, there's only 3 that are matched and that are shared in these 2 charts. That's T Series, Set India, and Coco Melon Nursery Rhymes. And I thought that was pretty interesting because that kind of gets away from that narrative that we were thinking of where, the more subscribers, more earnings, but here is not necessarily so for like the top. But it also reinforces that fact that we were seeing US and India had most of, the earnings and subscribers, and that's seen here by color. We have each country, and there's a lot of orange and a lot of blue. And India, US make up 80% of the top 10 in both of these. Yeah, so another interesting point here is South Korea on the top in earnings was very surprising to me. These were Korean letters that I couldn't translate in Python, but Kim Pro was at the top, and I was really interested in how, why is it South Korea? Why is it Brazil, Russia, and Japan? Is there something going on with countries that we could kind of dive into a little further to see why these countries are popping up in these charts? And so I did a deep dive into the box plot data distribution of, on the left, subscribers, and on the right, highest earnings. There's a lot to look at right here, but after, taking my time and looking at this chart for a really long time, I saw that there was, a pretty surprising trend. And we see that here with South Korea, Pakistan, Turkey, Italy, and Germany. If we could see here on the left, there's similar distributions of data for subscribers, but on the right, they have a completely different distribution than those neighboring in earnings. And that was pretty surprising to me. I wanted to know kind of more about that and why there is such a difference in this small subset of countries. So this is an opportunity to kind of dive deeper. I separated those 5 countries from the entire data set. And as we see here, their mean earnings were more than double, way higher. And I thought this was very surprising because this is a huge difference between these 5 countries. And this could be an opportunity where if you're in a country that doesn't have the highest population, or you don't have the most YouTubers or anything of that sort, you can, look deeper into the data and find out, is your country acting like one of these countries? And so in order to kind of get more into that point, I wanted to find out what's going on with, the other variables in this subset of countries compared to the total. So I came up with a heat map. On the left, it's that subset of countries, again, those 5. And on the right is the rest of the countries. And there's a lot going on here. So just to start, I want to point out this highlighted one here. This is video views for the last 30 days. And it's highly correlated with highest yearly earnings. And for the subset of countries, we found that it was very much very highly correlated with highest yearly earnings compared to the entire subset. So this kind of leads to opportunity where if you're in a country like one of these subset countries, your goal could be to pump out as much content in the shortest amount of time within that 30 days to get your highest yearly earnings. Whereas if you're in a more of a country that has these trends, if you're looking for subscribership, your video views is your highest correlated. Maybe that is something you want to focus on instead. All right. Yeah. So a ton of different strategies and implications you could use this. I just want to point out a couple ones, not overcomplicate it. complicated graph. So some takeaways here is, you know, you don't need to be the top YouTuber. You don't need to be the top YouTuber or in a country that's the top to be a successful YouTuber in either subscribers or earnings. There's a wide range, and you can be in a multitude of different countries to be successful. Different countries can have varying correlations to success. This could lead to opportunities in like VPNs. Like, you know, what if YouTube has an algorithmic feature that's promoting a certain country a certain way, and you can use your VPN to put yourself in another country virtually. That's something to explore further, but that is, you know, just things to think about when you're thinking about country. And, you know, there's also other things like it could take a while for a country to adopt YouTube kind of in their society. You don't know if like it's a regular, like in the US, a lot of things are on YouTube. You don't know if that's true for other countries. At least I don't. There could also be, you know, nationalist effects on that sense too. Maybe, you know, maybe Italy's just that way because Italians like watching Italian videos. There's more research that could be had there, and I think that's something interesting that could be further explored. But to maximize earning potential in that sense, it might be best to find a country that's behaving like the subset ones that we found and try to attain as many video views and subscribers in that 30-day period as possible. All right, so in terms of, we were looking over country before, we're delving into categories. I wanted to explore that phenomenon a little further. Can one category be better than another? And is that important in creating content or these channels? So from here, what we could see is, you know, the top three categories that we saw before: entertainment, music, and blogs. They make up 63% of the total earnings in the data set, which I thought was, you know, I thought it was like pretty surprising that they had that much of a commanding amount of earnings. And another thing to note here that was also really interesting, if you remember back, we had gaming on that top 5 scatter plot before, and gaming's pretty far down here. And there are a lot more different things that could attribute to that. So I want to explore that further in a sense, like kind of like that subset approach. And where we have here is entertainment has a kind of regression plot that's going, you know, straight upright, and that means highly correlated. Like for one subscriber, you're going to get more earnings compared to gaming down here, where, you know, it's flatlining out. So if you're somebody who's very passionate about gaming, these people are all still making a lot of money and like subscribers with their channels, but it might make more sense if you're in it for trying to gain money to start out in a category like entertainment, so that you can maximize your earning potential. And, you know, if you logically think about this, the way I thought about it is, there's probably a lot of young people on gaming. They might not have the money to spend, whereas people who entertainment could be, you know, all different types of people coming from work, they want to watch a show, you know, even young kids that want to watch shows and parents to buy it, things that sort. I just think it was more earners correlated higher to entertainment logically in my head.
2 of my young kids watch only gaming on YouTube. They watch how people play game.
Oh yeah, like stream. Yeah, that's what I was thinking. Like, are streamers really making like that much money off of like these subs than, you know, in entertainment getting like a subscription for a show? I don't really know if like the money's there in that sense, or if they have as big a crowd, but I would love to see in that sense, like kind of like a loyalty metric. Like, I'm sure your children like follow the same streamers like
Oh, they
hardcore.
just watch everything on Minecraft.
On Minecraft, yeah.
Yeah.
Yeah, like a category specific analysis would be great to see like what streamers are doing what to kind of keep them coming in and subscribers. But anyway, yeah, so takeaways for there, other than Vivian's children love Minecraft. The top 3 categories are entertainment, music, people, and blogs, commanding amount of earnings. And normally I would say that it's very in line with like what we were seeing with like a lot of the initial country observations, but, you know, a lot of YouTubers doesn't always mean, you know, the most subscribers and earnings. We saw with gaming, it wasn't necessarily the same. All right, so I also wanted to kind of do my own spin. Oh, actually, sorry, let's back up for a second. I did analyze uploads, and I thought this would have, you know, more of an impact on success, but as we could see, like earnings or subscribers didn't really correlate well with uploads. And so I figured you know, if you're going to have a lot of uploads, it doesn't really matter too much. They have to be like quality uploads that are going to get you earning some subscribers, but that's also what we have here. So it could mean a lot more different things that we don't have access to in the data set. More research is required to make any conclusions about uploads. The earnings per subscriber is something I made on my own. Like I took, you know, earnings divided by subscribers. I want to see how much earnings each YouTuber is making per subscriber that they gain. And so we see the top two from top earnings here, Kim Pro and Defuk Boom. So there is like a way to kind of gauge yourself, and like, so like you're looking at your subscribers. If they're like low, you want to look at your earnings per subscriber and see, you know, is my earnings per subscriber low because I have a high like earnings per every subscriber, or is it low because I have so many subscribers and I'm not making much money off of what I have? And then going back, we could see what correlates to earnings to try to raise that, or if we want to look at subscribers, see what raises that. Like, so in terms of earnings, you have to pump out, you know, 30-day content, whether it be video views, subscribers, things of that sort.
Brian, did you actually check out those YouTubers? I just checked out Kim Pro.
What do you say?
I just checked out the Kim Pro. Did you?
I didn't go specifically in like what, like I looked at the second guy, Defuk Boom, and I've actually seen him on Instagram before. He creates some crazy videos.
I think most of them make like TikTok type of small, funny video on the 10 seconds, and the video is not even complete. So you were like, did I miss anything? So you end up playing it many times.
Yeah, and that probably attributes to their video views, and kind of maybe if they're short term, like people are like, oh, I don't want to miss one. Like Defuk Boom has like this whole like narrative and like story going on where it's like TV, like television people fighting these toilet head people, and it's like this apocalyptic reality where they're all fighting each other. It's like, I don't understand how are you making millions of dollars? But nonetheless, here we are. So furthermore, I created another variable here, view conversion. I figured it would make sense, like for every subscriber you get, how many video views are you getting? And I didn't really find any cool trends here. So I just want to show something I thought would be cool that wasn't actually, you know, very meaningful to me. But maybe going forward with other variables, we might be able to do something with that. But links, this is a variable that I did on my own spin. So for the top 10 earners, I went into each profile and I took their links manually and I gave them a variable inside the data frame. And so what we saw here is like for the top 10 earners, the more subscribers or the more links you had made out to having more subscribers. And the same with video views, whereas yearly earnings, it was almost like flat, didn't really have much of an impact. And I thought this was interesting because eventually it would be cool to do like a web scraping thing where I could get everybody's links and see if that's an actual trend. If it is, then you could see like, oh, like this top YouTuber has 8 links, and like one of the links to their TikTok, one's to their Instagram, one's to their store. Maybe this is why they're getting so many subscribers, because they're doing like a cross consumption across different platforms. And that starts with having a certain amount of links. Cool. And yeah, so you think you can all go out and make $1 million on YouTube now that you watch this?
My
Probably.
kid dreamed about having become Miss Beast for Minecraft. They tried several times to record their game.
Yeah,
They're like,
yeah,
this is my dream career now.
I mean, yeah, it would be nice if I could just, you know, play Minecraft and just make millions of dollars just making videos. But yeah, the reality is this isn't really going to make you $1 zillion like Mr. Beast. Just like the takeaways that I got from this were, you know, upload amount, small effect on earning subscribers, you know, varying earnings per subscriber in categories per category. Countries can have varying correlations, and that one correlation was a 30-day activity. Some countries you might want to just like pump out quick content and within 30 days. The most YouTubers, subscribers, and earnings, YouTube, US, India. Adding links to your profile can help bolster subscribers and video views from what we've seen in this data set. And if your earnings per subscriber is low, you can evaluate why and how just, looking at earnings and looking at subscribers separately to increase and decrease that. And of course, other considerations. There could be a lot of reasons why I'm wrong. Like nonprofits and activism, I was looking at, like, is their goal earning and subscribers, or are they kind of trying to bring attention to their causes and things of that sort? And kind of links, like, you could think about, like, maybe their success is coming from, like you were saying, they're making YouTube and they're making TikTok videos. Like, are they successful on YouTube because they're TikTok, or are they successful on TikTok because they're YouTube? A lot of other things to think about there. And yeah, it's not an all-knowing presentation that's going to make everyone $1 million. It's just a place to start one's creator journey or help their creator journey, and kind of use data-driven approach and figuring out how and why for your other creators. And future works, more data would help. I would love to see, like, video length, the names of titles, like how they cross consume in their other videos, like the ads. Instead of like 1,000 YouTubers, I'd love to see like 10,000, 1 million, things of that sort. Dive further into like that viral thought, like how can we like measure that even further? Time data, would love to see a time series analysis of like YouTubers. There's consultative ideas around, helping YouTubers help their brand. I was mentioning advertisements, and a multi-platform analysis would be cool too, like being able to look at Snapchat, TikTok, Instagram. How are they all doing and how do they feed into each other? Cool. And that's it. Any Q&A and feedback from anyone? And I want to thank Vinod. Vinod was great. He helped me so much.
I can tell it has a Vinod touch.
Yeah.
So just one quick comment. On one of your slides, you said there are soft correlation, but in statistics, there's no such terminology called soft correlation. You should use high or low correlation.
Okay. Yes.
Just look like it's very, very technical term.
Cool.
Yeah, the rest look great. Any other comments from the audience?
Oh,
Brian,
I also, I see Zach's here. I want to thank Zach. I want to check out this table of contents over here. This is all Zach right here. I looked at his Jupyter notebook. I'm like, I'm going to use that table of context framework and make mine off of that.
Yeah, thanks for the shout out, man.
Brian, can you hear me?
Yeah.
Okay. I just had a quick question. I'm sure you already looked at this, but for the earnings column or variable, were they all normalized to the same currency?
That's a good question. It doesn't mention it in anywhere on the Kaggle set.
Okay, because that would be something that you would want to know, right? Because you might have, I don't know, if it's in different currencies, that could really affect the numbers that you're getting.
No, yeah,
like if your Korean subscribers were all in Korean won, like I don't know what the exchange rate is, but you can't really compare that across different countries if they're not all on the same currency.
Yeah, no, that's a great point that I didn't think of like at all. And now I'm looking through the Kaggle to see if there's any mention of it, but there's actually like no mention of it at all. So I'm going to be looking for that.
Yeah, I'm surprised that they don't mention that at all, actually. But okay, cool.
It's earnings from the channel, and I was looking through the discussions too. There wasn't any mention of any like earnings like describe it. So that's something I'll dig into more, and I'll message you on the side about that once I find it.
Yeah, I think Miss Beast is one of the top paid YouTuber. So if you tell me another Indian YouTuber get paid more than him, I would be like, could that be possible?
Yeah, he was top subscribership, but he wasn't even. There was some other US ones that were above him in the top paid.
Yeah, I know.
Was it revenue for the videos, or was it just the earnings in total? Because I know Mr. Beast, he makes a lot of money, but I think he also spends a lot of money, if I'm not mistaken, right? So I'm sure some of his videos might even be net negative, right? Because he's spending, like, he did the whole Squid Games thing himself. I'm sure that cost him a fortune.
Yeah, from what I was like trying to spot check some other ones, and from what I gathered, I believe it's earnings from like total about like their entire, just like, their net worth.
All right, thanks.
Actually, great question, Ray.
Do you have Jeffree Star in your list? The cosmetic YouTuber?
Sure.
I know he got paid a lot too.
How do you spell that?
Let me send you his brand so you can look it up.
Jeffree Star Cosmetics.
Yep.
Yeah, I'll look into him.
He's among like one of the most viewed YouTuber around makeup.
Yeah, so it makes sense he's on this list.
Oh, thank you.
Thank you. Sorry,
Okay.
I'm gonna try to find Jeffree Star in the data frame.
Okay, let's move on to Isaac. Are you ready to go?
Yeah,
Go for it.
sure. Let me just share my screen. Yeah. You guys all good? Cool. So this is the machine learning project. Just a little bit about the data set. I mean, everyone has the same data set. It's from this Kaggle competition about advanced regression techniques for a housing data set, and all the houses are from Ames, Iowa, and it has about 81 features, and the goal of this whole project and competition was to predict housing prices using different machine learning techniques. So I used a couple different models, and I engineered a couple different features to try to improve the score, which I believe was the whole focus of this project and competition. So some of the models I used in kind of the intro to the structure of my project. So the structure of my project was, basic EDA, looking at the data, some pre-processing to make everything the way I wanted to, a little bit of feature engineering. I checked through all the multiple linear regressions assumptions, and then it was fitting the models and then tuning them. Some of the models I used were Lasso, Ridge, Elastic Net, and a random forest. And I'll go into more about all these bullets in the project. So some of the data pre-processing I did was I used the log transformation on the sale price. I have a couple graphs to show later on, and then using the log of the sale price column made it more normally distributed, because at first when you look at the sale price and you plot it as a histogram, it wasn't normally distributed, and it had a really long range. And when you take the log transformation of that, it also makes it more normal, and it compresses the range for you as well. I removed any columns that had a lot of missingness. So I just went through and looked at any columns that had a large amount of missing data. There was a couple features that had a high amount of missing data, so I just removed them. Stuff like what I think it was stuff like I don't know if I had it. It was like alleys and pools and stuff. So not every house had an alley, not every house had a pool. So there was not enough data for the model to kind of learn anything. So I just removed them. There were also 2 outlier points in the data set that I also removed, and we'll talk more about that in the next slides. So this is the distribution of sale price. This is before the log transformation. So you can see how the QQ plot, it's not against that theoretical line for a normal distribution. And then you can see over here for the histogram that it's definitely skewed to the right. And I actually have the skew down here. It's 1.88. So I think a normal skew for like something perfectly skewed is a 0. So it's a positive value. So it's skewed to the right. And you can see that this left side kind of ends, and it has this big tail on the right. So it's definitely not distributed normally. So again, this breaks, the linear assumptions. So when you take the log transformation, it looks a lot better. It looks a lot more normal. And then when you do the skew down here, it's a lot closer to 0. And it actually compresses the range too, which is kind of nice. And then when you see the QQ plot, it's much, much closer to the line here. You can also log it again, but I didn't think that was necessary. It does get it a little bit closer to this line, but I thought the just one log transformation looked fine. And then for identifying outliers, it took me some time to figure this out. But when I was looking through the scatter plots of sale price against other things, this is just a scatter plot of sale price against, this is just like above ground living room area. You see these 2 points out here that I circled, that they have a really high area, but they sold for, a price that you wouldn't expect. You'd expect it to have some kind of, linear relationship here. So I removed these 2 points, and this was the QQ plot of that before. And you see these 2 points kind of exerting pressure on this line. So I removed them. And again, this QQ plot doesn't look that great, but I think it's just because of the y-axis range is very small here. So it actually is very close to this line here. So remove those 2 outliers, looks better. And then I just added this for everyone. If you're not at this part of the bootcamp, we went through the 5 linear regression assumptions here. So making sure that there's a linear relationship between the variables, there's constant variance between the errors are normal, the errors are independent of each other and they show no pattern, and that we removed any columns that had any multi-collinearity. So this is just an example of some of the scatter plots I looked at. Again, I looked at them for sale price against all the other features in the data set, and made sure that there was some kind of linear relationship here. And you would expect there to be one, right? A lot of the features were something about some area of some room or the year something was built, right? So you would expect, stuff that was built more recently would have a higher sale price. Stuff that had more area would have a higher sale price. And then this is just like year built. So you can see, there would be some linear relationship there, year remodel added and stuff like that. So for constant variance, I just did a residuals versus fitted. And this was before I removed the outliers. You can see those 2 points there that are really kind of far away. And then once those outliers are removed, right, when we're looking at the residuals versus fitted on the right side, you can see that, there's no kind of pattern and the variance is kind of constant throughout. There's kind of like, if you look at the line on the, at 0, you can see that, it's kind of equal amount of points above and below the line. So it's pretty even variance and there's no kind of shape or pattern to the errors. So they're independent of each other. And then just looking at the normality of the errors to the density plot, looks pretty normal. And then a histogram and then another QQ plot. And then to look at multicollinearity, I looked at, I just broke the data down into subsets. And then I looked at like a couple features at a time and saw their correlation with each other. And then I was just going through and removing any that had a correlation of about like 0.7 or higher with each other. So in just this example, these make a lot of like logical sense, right? So you have like above ground living room area is heavily correlated with total rooms above ground. So you don't really need that. And I just kept the variable that was more descriptive, right? So I care more about the actual area because that's, a more mathematic calculation rather than, total rooms above ground, right? Like maybe someone has, only one room above ground, but it's gigantic, right? So it's not as descriptive as, living area. And then another example here is the number of cars that a garage can hold and garage area. Obviously that makes sense that they're very correlated with each other, right? Bigger area means, more cars can fit in it, right? But I kept garage area because garage cars maybe is not as descriptive as I would have wanted it to be. And then again, I made like 7 of these or something, and then just went through all of them and made sure there was no multicollinearity, and then removed any columns that had it. And then for my first model, I just tried a lasso model. The first thing I did was they have a CV package in sklearn. So I just tried a bunch of different alphas, and then the lasso model tends to prefer, at least for this data set, it tended to prefer smaller numbers. So I put a lot of small values. I did the crossfolds at 10, and I needed to up the max iterations because some of these values were so small it was not converging. So the optimal penalization term it found for the alpha was the small number at 0.0005, and that low penalization term means that less coefficients were reduced to 0. And then, yeah, I fit the model, did the predictions, found the mean squared error. I converted it to root mean squared error because a lot of people were using that as their, their scoring metric. And then I found the R squared as well, which is 0.9. And then I did the length of the coefficients in the model. So it had 230 coefficients. And then the lasso model, the optimal one with the 0.0005 alpha, it reduced the model down to only 96 coefficients. So it reduced a lot to 0. And that's kind of what lasso is good for, because it's really good for feature selection, right? Because it's reducing those coefficients that it's not finding useful. So good model for that, and pretty good scoring, and not the lowest mean squared error, but it was pretty low. I also did a ridge model to compare. Ridge tended to like these higher values, so I did kind of the same thing, right? A cross validation with different alphas, fitting the model, finding the optimal parameter. It liked the alpha of 14. So it had a high penalization term, which means more coefficients were reduced towards 0, but ridge never reduces them to 0. And then again, ridge scored a little bit better. It had a very, very slightly lower mean squared error. And then I was just looking at the length of the model here. So it had 230 coefficients. And then we checked the sum of the coefficients that aren't 0 here. It says we lost 3 coefficients, but I'm sure it's just a rounding error, and that 3 coefficients just got reduced very, very, very much, and they got really close to 0. And then this is kind of a good model if you want to keep all the features and you don't want to kind of do any feature selection, because it's keeping all the features in the model. I was going to just leave it with lasso and ridge, but I decided, maybe I'll try elastic net because it's kind of the combination of 2 of them. So again, it's kind of the same thing. You use the cross validation package, and then I use similar alphas to both the ridge and lasso model, but it has this extra parameter here, which is called an L1 ratio. And that is kind of how similar it is to a lasso model, right? So if the L1 ratio is equal to 1, it would be a perfect lasso model. And if the L1 is equal to 0, it would be a perfect ridge model. So again, found the optimal parameters. Again, still liked a very low alpha, and then it liked an L1 ratio of exactly in between a ridge and a lasso model. So unfortunately, it was not as good as the ridge model from the mean squared error, but again, they're all extremely, extremely close with R squared and mean squared error. And then I also wanted to do something that wasn't, a multiple linear regression model. So I decided to do a random forest. This is a lot more parameters. So I used a parameter grid for the cross validations with different estimators, different max depth, different splits, and different amount of leafs. So again, fit that. This takes a long time to run, but when it was done, the parameters that it liked was a max depth of 20. So that means from the top to the bottom of the tree, like from the first node to the terminal node, it was 20 long. And I have a picture of it later. And then the minimum samples that the leaf needed for each node, so to be split, it needed at least 2 samples. And then the minimum samples required to perform a split at that node needed to be 4, so it could split that into 2 and 2. And then it used 200 estimators total for the ensemble to make the final model. This was for the data set that was 1-hot encoded. I also tried it with a label encoded model as well, and it actually had worse scoring. So I just kept it with the 1-hot encoded data set. And then I found this cool visualization on Stack Overflow, and I just used similar code to the guy posted, and you can get kind of the output of your model. So this is the model that I ended up with, right? So it's about 20 long, and each tree you can see is only split into kind of 2 each. Again, I wish I could show you it. It's just a really large file because of how like in depth and how many splits there are. And you can see like it has the variable here, the feature here, right? So like houses that have above ground living area greater than this number, right? We have 32 of them, and then it splits them into 2. And then at the nodes down here, there's just not enough samples left to split from that previous value. So thought it was a cool visualization that you can see like the random forest that you created. Another graph that goes along with the random forest is the feature importance. So the random forest model really liked overall quality, and I suspect that's because random forest deals a lot with feature interactions. You would assume off the bat, right, that area and stuff like when stuff was built would be the most important feature. But again, random forest really liked this overall quality feature the most and decided it was, it was very important for the model. But again, that makes sense, right? Maybe, if a house has an overall higher quality, right, it means, it has a higher square footage, stuff was built more recently, stuff like that. And then for the model comparison and scoring, I used the root mean square error to score each model, and I also used R squared for all the multiple linear regression models. The model with the best scoring ended up being the ridge, and that makes sense, right? Because it includes all the 230 features that we looked at, but they all scored very close. And then here's just a graph of the root mean squared error. Again, it's super close. You can barely even tell the difference, right? But it was ridge, elastic net was in between, lasso, and then it was the random forest, and then it was the random forest label encoded as the worst one. And then I converted it back into US dollars because this is kind of hard to interpret. So I converted the root mean squared error to USD just to make it easier to interpret. You have to undo the log transformation originally, right? So you logged the target variable. So to undo the log transformation, you have to do this exponent function from NumPy. So you do np.exponent, and then you undo the log transformation. Then you do your predictions. Then you can get the mean squared error, and then you square root that to undo the square, and then you get your original units in USD. So again, so the average error was in the tens of thousands. I wish it was smaller, so these models, so on average are like about 20,000 US dollars off. So again, not bad, but also not great. So I know there's more work to be done. And then some conclusions and applications to real estate. So some basic uses, right? I think it was talked about in the project intro, right? You can use it for any kind of home price estimation website, such as Zillow, just for like general browsing. And I thought like if you're missing any data on a specific home, you could use more simple models, right? Maybe, you can't use a ridge because it requires all the features to be input. That's same with the random forest, but maybe, you only have a limited amount of features and you can use kind of a lasso model to kind of get around that because it's going to be a less complex model with the feature selection as opposed to feature reduction. And another thing you could do is you maybe create a website with a UI for home buyers or sellers to kind of input the features into their home, and they can kind of run the models themselves and get an estimate. I think that would be pretty cool. It can help users see what features impact the house price the most, in their area. Maybe they could see if a potential remodel was worth it, right, by checking the remodel per year, like when it was built. And it can help users get an idea of a selling price or a bid for a home, because I know a lot of people, that's kind of tough to do. And I know that's a big thing that people get, like you have to send someone out to get an estimate for a home. And then, if you're bidding for a home, how do you know, that you're getting, a good price comparable to, other houses in the area. And then some other conclusions, these are more personal conclusions. So I found that feature engineering was very, very important. I came into this project thinking that, tuning the parameters was going to be the most important thing. But I definitely found out that feature engineering was definitely more important. I kind of fit all the models before I did any feature engineering just to see how the scoring was before and then after the feature engineering. And that definitely improved the scoring the most as opposed to just tuning the models. So, if I could go back and redo this project, I would definitely would have had a bigger focus on feature engineering and some future work. Just work more on feature engineering and learn more techniques, right? I want to look more into principal component analysis. I know there's another one called kernel PCA. I looked up something called clustering, and that's all stuff that might be more applicable to other data sets. I didn't really create any of my own features, and now looking back on it, that's probably a mistake. There's definitely a lot of easy ones to do. Like you could probably just do total area of the homes, and you probably just could have added up all the areas there. I'm sure that would have been a good feature to add, and maybe importing other features from other sources that might be relevant. And then, I want to learn about other models to use. I only know about a few models so far, and they only have a few parameters to tune. So maybe working with more complex models will have, more parameters and stuff to tune. And that's it.
Perfect. What's the main takeaway after trying so many different models?
It's definitely the feature engineering thing. That feature engineering is probably the most important thing, and how you deal with that. For the models, I guess it kind of depends on your data set. right? And kind of what you want to do. Because like if you want to use like a very complex model, you can go with random forest if that's more applicable to your data set. If you want to go more simple, you can kind of go the multiple linear regression route. And if you want to keep all the features, you can go ridge. And if you want to like feature selection, you can go lasso. So it kind of depends on what you really want to do. So that's good to know. So it kind of depends on your goal, but yeah, the big emphasis would be on feature engineering for sure.
For decision tree type of model, you cannot do one hot encoding, which means turning dummified variable. Otherwise, like decision tree were and really focusing on purify the node. So once you do one hot encoding, 0 and 1, very likely one particular split will be like 100% purity. So it's
really?
going to largely impact your model.
Huh, I didn't know that.
You should avoid one hot encoding before
Okay.
you do any tree model.
Okay, sounds good. I'll keep that in mind for next time.
Yeah. Because like every one only turn on but when they belong to one category.
Okay.
Okay, cool. Did you get a chance to compare your own work with previous other students' work?
No, I did not get to do that yet. John was telling me that you used to be able to send it into Kaggle with like a CSV of your results, and they would give you a grade. I don't know if they still do that though.
Even if the Kaggle competition is already ended, you can still get a score.
Oh, so you can still send it in?
Yeah, it just
okay.
count towards to the award.
I thought when the competition was closed, it meant no more submissions. Okay, yeah, maybe I'll send it in and see what they say.
Yeah. Cool, awesome. Do you feel like you're in good position if someone give you a new data set, ask you to model and predict, you already have pretty much 60%, 80% of the code to get started?
Yeah, for sure. I think I would just need to work more on the feature engineering side of stuff. And I feel like it'd be harder if it was a data set that I didn't have a lot of domain knowledge about. It would be harder to kind of engineer my own features. But yeah, for the code and stuff, it's pretty straightforward.
If that's the case, you should look into how feature engineering is typically done for
Yeah,
different
yeah.
type of data set. Then you can have the script to standardize your practice.
Yeah, I was watching a couple of videos and stuff, and there's a lot of information out there.
It takes quite some experience.
Yeah.
Like we showed you a few examples in the video recording, like the diamond data set. How can you know once you turn this into log scale, it's going to be linear regression?
Yeah.
Right? It takes experience.
Yeah. And it probably just takes seeing other data sets too. So yeah, to get practice with. So yeah, this is definitely good practice for sure.
We taught a few transformation like box-Cox transformation. Like those are very standard approach how to feature engineer data.
Yeah.
Transform it so it's can be an ideal candidate for different modeling technique.
Yeah.
So those are also things you should build into your scripts.
Yeah, for sure.
Awesome. Okay. I don't have other question. How about the audience? I know Isaac already finished this project. You're moving on to your capstone, right?
I have a question.
Yeah.
Yeah, sure.
No, I didn't do this project yet. This is the next one.
Oh, you're doing capstone and machine learning at the same time?
I need to do the machine learning and then I'll do the capstone, but Joe is a little bit slow. So right now I'm watching the classes.
Okay, got it. Yeah.
So
I actually met Joe on Sunday. He stopped by New York and his niece go to the same baseball little league with my kids. So I actually met at the baseball field.
Okay. So first of all, very good job. It was very good to see it, so I can have a great example of what I need to do. I have a question regarding the target variable, the one that you took the log in the beginning. Yeah. You did it to normalize it, correct? Because it's one of the assumptions of the linear model.
I don't know if normalize is the correct term, but it's not normally distributed. So you want to get it into a normal distribution, right? Because it's very skewed to the right side here. And you can see on the...
Why is this a problem? Aren't the errors needed to be normally distributed, like this variable can have any distribution it wants. Isn't like that.
I think it's mainly to improve model scoring. It also compresses the range. So again, I don't know if I have enough background knowledge to answer that question, but again, this is not to do with the errors. This is just the target variable.
Mhm.
Yeah. Maybe Vivian can answer that question better.
So QQ plot usually used for detect how normal it is. If it's a perfectly normal distribution, you should see the blue point line close to the red line.
Yeah,
So
but
this is more
do you need it to be this normally distributed? Why do you want the target variable to be normal distributed? That's the question.
Zach, do you want to answer this one?
I feel like I did have the answer, but since I took a week off from, I pushed my presentation back. I don't know if I have it off the top of my head. So it's all you.
So for linear regression, there are 5 assumptions. One of them is normal distributed.
Of the errors, the error
Yeah.
needs to be normal distributed, not the
Yeah.
variable.
Did you do a variable plot or the error plot?
Well, the sale price, I did the log transformation of, which is the target variable.
I see. Usually you do QQ plot on the errors. So after you fit the model, you want to see, is there any other pattern
Yeah.
error you haven't
Well,
absorbed into the not
This is after I fit the model. This is just looking at the sale price distribution, and it was looking at after I fit the models before doing all this, and then I fit them
Okay.
after, right? So this is the QQ plot before this. Well, it's after fitting, but before the log transformation, and then you do the log transformation here, and it fits much better.
Okay.
Are you plotting the price directly, or you're plotting the error term of predicted sales price?
Oh, it's not even in this notebook. I can go to the other notebook. Let me. It's been a while since I opened this big old notebook.
No worries.
Yep, this is distribution. This was houses sale. What did I do for houses sale? I was just looking at the sale price, so maybe it wasn't even. I was just seeing if the sale price was normally distributed. That's all it was for.
Okay, so it's a good exploration, but it's not required. The only required QQ plot is the error term QQ plot.
Okay, yeah, that was it. It was just yeah.
Yeah, so you can fit another QQ plot after you fit the model.
All right.
The main reason we do that, we want to make sure there are no systematic pattern in the error, which usually means your model haven't absorbed all the signal yet.
Yeah.
Okay, sounds good. Thank you for pointing that out, Isaac. Awesome. Any other question? Okay, everyone have to do this same computation. That's the only fixed topic project we ask you, because this data set is so special. You can fit anything and everything you learn in machine learning section. So it really give you an overview how model compared to each other. And also, if you have more time, you can try to ensemble model and the stack model. So you can use the first layer models output as input of the second layer of a model.
Yeah, I'm sure once I get closer to this, I'll have a lot more questions about it.
We have thousands of existing projects you can double check. Also, students have done like sharp p-value, try to see which criteria. If you update the house, you can get much better sales price. Or are the key factor to get better sales price. So feel free to check out all the existing work. You can go to the blog site and click on machine learning project. I think there are at least 500 project blog posts there. Sound good?
Yes.
Awesome. Okay. Isaac, if you are looking for partner of machine learning project, I have 2 other candidates who want to collaborate, but I can make a group so you guys can talk, see whether it's going to be a good fit.
Okay, thank you. I'll let you know. Like I'm still looking. I'm still in the classes. So
Yeah, they are in the class too. They are looking for partner to start in early November.
okay, I'll let you know next week.
Okay, wonderful. Great. That's it. I'm gonna wrap it up. Thank you so much for your presentation. And Zach, you're moving forward to the capstone. So we should find a time to chat. I have a lot of generative AI projects if you're interested.
Yeah, we gotta find time.